Welcome everyone. This is my 3-pound Beetleweight combat robot Vortex. It's a shell spinner, also sometimes referred to as an FBS or full body spinner, meaning that the entire outside of the robot spins. Just a quick overview of this robot. You have the shell on the outside, which has 2 teeth on opposite points, and then a top bar here, and then all of the internals underneath of the shell. So some of you may be wondering, what is this top piece for? This top piece actually does 2 things. One is tell me the orientation of the robot when the robot's driving around, because the entire outside is spinning, so it's oftentimes quite hard to tell where you're going and what orientation your robot is in. However, this piece is mounted to the base, so when the robot turns, this piece will turn at the same rate. The other point of this piece is to help reorient the robot if it's inverted. By spinning the base, this piece will spin and flip the robot back onto its wheels. We can remove this top piece by unscrewing one set screw hub on the front, and this piece will come right off. It's just a hub onto a rather crudely cut piece of aluminum here, and then a piece of PVC that has been bolted and epoxied to this aluminum piece here. Next we get to this big beefy collar here. This is just a clamp to keep the shell from flying off. So untightening this with this Allen key, we can pull up and pull this piece right off the shaft. Then we can remove this piece here, and that allows us to get down to the shell. Now, in the shell, between the motor here, when I rotate the shell, you can probably see the motor here rotating with the shell. That's because there's this belt here, and we can go ahead, reach in here, and just pop that right off. So now the belt is loose, and the shell can pull right off. This is one of 2 shells that I made for 2018's competitions. This one is pretty beat up, but it actually only went through 2 fights at Horde during the Rumble, and then 1 fight at Cirque. The other shell was the shell that was primarily used, but that one got almost completely destroyed in the Cirque Rumble. As you can see, there's marks the whole way around, courtesy of Ataxia, which was a very powerful horizontal spinner, and then the top piece here is actually completely disconnected. Getting down to the base here, we can pull off the belt here, and then there's 2 washers here. We can go ahead and set those aside. And then we can see the layout of the robot. So, going over it, we have 4 brushed DC motors that control each wheel in direct drive. These are the Light Flight 1.25-inch foam wheels. They held up quite well. I did have to replace them a couple of times, and the grip was alright. I might do something with this in the future. I'm not exactly sure what I want to do with it yet, but they held up pretty well. The motors are powered by 2 FingerTech ESCs on either side, and they are just running in parallel off of those. Then we have the battery, the power connector, battery switch, and then on this end we have the motor ESC, and the receiver. There's really not a whole lot of clearance here between the motor ESC and the motor and the receiver, but I never had them run into each other or have anything get chewed up in there. So I'm actually quite happy with that. Getting on to working our way through this, removing the battery is actually quite simple. You just go ahead and remove this one piece here, and that pulls this screw out. We can get to the battery here. There's this little 3D printed clip, and the battery slides right out and can be disconnected. These are the new graphene batteries that actually match the shell. color scheme quite perfectly. I was really happy with that. But these are the Turnigy graphene batteries. This is a 500 milliamp hour battery, 3S. I think I will be upgrading to something with more power in the future. This just did not have enough to last me through the fight. Originally at Horde, I had larger batteries in, but they had a tendency to want to fly out and get caught in the shell as it was moving by, and hitting your weapon against your own battery is usually not a good idea. Moving around to this end, removing the motor is actually quite simple. There's 4 little screws here. The motor comes right off. I just have 3 bullet connectors here on this, and those hook up to the 3 bullet connectors on the ESC. And then you can sort of see into the receiver here. I have some of the wires hooked up here. These will go to the weapon ESC and the 2 drive ESCs. There's really only 3 major functions on this robot, so it's really not complicated in that aspect. Then getting onto this shaft, it is held on by 2 set screw hubs, which you can see right down in there. The shaft can pull right out. This is what I was talking about of the stainless steel dowel pin. It's about 4.5 inches long, stainless steel, and incredibly tough. This, I've run it with in every single fight, on bushings, on bearings. I've seen absolutely no damage to this whatsoever. It's held up amazing, so happy with that. And then this top plate here goes ahead and comes off. I do already have some of the screws out, so that comes out. Set screw hub right on there, and then just a couple of rails here. That's pretty much down to the bare bones of this this robot. Not the cleanest wiring in the world, but it works. All of the motors are connected on these 3-wire pins that I've actually converted into 2-wire pins because I had a number of these 3-wire ones lying around. So I just went ahead and used those. That about covers it for my for the teardown of my 3-pound combat robot Vortex. It's a rather simple design. However, getting the weight balance on the shells and the gear ratio on the motors and making sure that nothing hit. My first test, I had a lot of issues with things getting caught in the shells, and even at Horde, I had a one of the connections on the battery or on the motor ESC had gotten caught in these holes in the shell, and this is moving at a couple thousand RPM. So if anything comes loose in the robot, since there's no for weight reasons, there's no top plate or anything on it. This base is actually a piece of garlite, which is fiberglass. You can sort of see here that it's got a fair amount of wear on the bottom around these edges, and it's painted black just because I think it looks better. But yeah, so the whole base of the robot is actually only about 1.7 pounds, with the shells, with the bolts and the teeth weighing in at about 1.2, 1.3 pounds on its own. So there's not really a whole lot of weight to work with in the base, which is why it's designed as lightly as it is, which is why there's no cover or anything to prevent stuff from getting caught in the shell. It usually comes down to a lot of just securing things in well, and then I'll usually cover these 2 terminals here with some tape just to keep the wires from coming up. This clip works out really well. I haven't had any batteries come loose from this because it's a very solid piece. These were sort of the last thing I got to. They're made of a couple of pieces. They have a ring piece that's an aluminum ring, and then they have this this top plate here. This was water jet cut along with these outer aluminum pieces, and then they're all welded together with these AR500 teeth sandwiched in and then bolted in between these two aluminum pieces. The welds in here on the inside, I don't know how well you can see these. They held up all right. Not the best design in the world, but it was all right for a initial run of this robot, actually getting it to compete and able to do something. But I think the shell design is going to be a lot of the focus on improving this, as well as just making sure I can fit a better battery that can last the whole match into the robot. So yeah, thank you for watching. This is the teardown of my 3-pound robot, Vortex. Good luck with your own builds, and I hope to see you out there at the competitions.